Chapter 9, Section 1, fill in the blank, nth roots. So this will follow the book, but I'm also adding in extra stuff because I want to make sure that you're getting the full concept. So these notes in 9.1 also kind of go over 9.2. So 9.2's notes will go super quick. 9.1 is a lot longer because it's looking at it graphically. And then 9.2 is more of the algebra, but I'm going to do both kind of in this notes section. So starting off, what is 3 squared? And if you don't know how to say that, practice it saying 3 squared. Remember, 3 is the base, 2 is the exponent. So that would be 9. What is the square root of 9? If you don't see a number on the outside of this root symbol, it's always going to be a 2. If you see a number out there, then that'll be a special root. So if I said cube root of 8, this would be the cubed root of 8. I could also do like the 12th root of 8. Those are both things that happen, but 12 is such a large number, we just say 12th root. This would be a special word called cube root, but you could also say third root. That's still accurate. It's just not as precise. All right, so square root of 9 would be 3, because 3 times itself will get you 9. So if you're starting with a positive 9, then we say the square root would be 3. But if you're thinking there's more than one answer, that's where we're going, down here, and I will correct it later. So find x in this first equation. If x equals 3 squared, then x equals 9, because 3 squared is 9. It's as simple as just simplifying it, and you're good to go. How many solutions are there? In this case, there's just one solution. 3 squared only gives you one number as the output. In this case, for the next equation, x squared equals 9. How many solutions are there? So something squared equals 9. You can take, if what you do to one side, you have to do to the other side. So if I take the square root of the left side, I have to take the square root of the right side. If I square root something that is squared, that leaves me with what? Just x. So x is going to be equal to the square root of 9. Now I hinted at something up here, but how many solutions are there to square roots? 2. Plus or minus is what goes in front, because for this, x is going to equal plus or minus 3. If I have a positive 3 and I square it, what do I get? 9. If I have a negative 3 and I square it, what do I get? Again, a positive 9. How many solutions are there? In this case, there are 2 solutions. That's not always true, so watch it, and there is a rule later we'll go over as well. But watch that. Just make sure that it could be a 1 or it could be a 2, depending on your situation. So the square root of it is an example of an nth root when n is 2. N is always what's on the outside of our radical sign. Sketch the graph of y equals square root of x. So you can plug this into your calculator, pause it now, try to do that, come back and see if you can match it. The square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and now I have enough that I can figure out my curve. Domain, there's no x values to the left. X values start at 0 and go all the way to infinity. So you could write this as all the values x, such that x is, greater than or equal to 0, because anything from 0 and above, or you could write it as including 0 going to positive infinity. Both of those work. Okay. For the range, there are no negative y values, so try this on your own and see if you can figure it out. Pause it, come back. On the range, I have my negative, I don't have any negatives, so it'll be the same thing. All my y's such that y is greater than or equal to 0, or including the 0, go to infinity. So it's actually the exact same answer. All right, and we'll finish off this first page for this video. Define nth root. So I want you to write your own definition, and then look at page 560 and see if you agree. Pause it, come back. On page 560, it says, let n be an integer greater than 1, then x is an nth root of k if and only if x to the n equals k. So k is the larger value. X is the nth root. So to show that you are an nth root, you have to show that this equation is true. So an example would be the second root, or the square root of 9 is 3. It's the nth root of k. So this is our k, it's our larger value. The nth root in this case is 3, which is the nth root. Okay, so find the cube root of 64. So you can plug this in your calculator. I'm going to go do classic first. So if you're in classic mode, so if you're in 83, type the 3 first, because for the root you want, go to math, and then under 5 there's an x. Yeah, there's 4, that's a shortcut, but 5 will work for any nth root you want. Click that. You have to type the 3 first for it to plug it in, and now if I did the cube root of 64, hit enter, it'll tell me the number. If you are in math print, you can do the same thing. It's nice because it plugs more stuff in for you. So if you go to the math button, go down to 5, it plugs it in and makes it look pretty. If you don't want to use the menu the long way, you can use a shortcut. So I'm going to type the 3 again. If you hit alpha window, in this shortcut it gives you 6, which is just the mysterious x. You have to type the number in first no matter what, but it does take you a little bit less scrolling to figure out, and now you can type in 64 and get your answer. Okay, so I'm going to get 4 as my answer. Now for this one, if I have 64 to the exponent of 1/3, it's 4 as well. So pause it, describe what you noticed. All right, so you must have noticed they have the same answer. Imagine that. So both of these are considered the cube root, or the nth root of 64, because if you do 4 times 4 times 4, you're going to end up with 64. There is only one nth root, or only one cube root in this case, because it's a cube root. So if I had -4 as the cube root, would I end up with a positive 64? No, these two would make positives, but I'd be left with a negative, and so I know that my cube root has to be positive 4. All right, and I also want to notice flower power. There's fractions in our exponents. So we have a flower above the ground, and underneath the ground you have roots. So if I had 256, we're just making up some numbers, 256, but I want to take it to the 3/2 power. So 3/2 power, that's not a nice whole number, so I can't take 256 times itself 3.5 times. That doesn't work. But this 3 is the power, and the 2 is the root. So to make my number smaller first, I'm going to take the square root of 256. Square roots will make your number smaller, as long as you're not in fractions, but typically it'll make your number smaller. So I'm going to do that first, is to make nice numbers. That's my square root. Now, this is the same thing as saying 16 cubed. So I took the square root, now I just have the power, and then 16 to the 3rd power will equal 4,096. So that's my final answer. I could do it that way, or I can do it with the 256 cubed first, and get a huge number. But this is all then square rooted. What do you think the square root of that answer will be? Look at that! It's 4,096. It's the same answer. So on top, your numerator will always be your power, or the exponent you're typically used to. This whole thing is the exponent, but this is the power, how many times you're multiplying it by. And then the root is in the denominator.